channel. Welcome to Practical Electronics 6. In this practical, we'll be dealing with DIY mobile phone power bank. As you can see, I have put up a power bank of 15,200 milliamp hour with output of 5 volts at 2.4 amps. So before we see what is in here, let's see how a power bank is made. Let's see the units that make up the power bank. Let's see the components, the major component that make up a power bank. But before that, let's take a look at the block diagram of a power bank. What we have here is the 5 volt DC input. Then we have the buck converter. Then we have rechargeable battery. Then we have boost converter. Then we have 5 volt DC output. If this is your first time of watching this video, please go to my YouTube channel and watch my previous videos. If you are new to electronics, watch my previous videos, all my previous videos on practical electronics. In our previous practical, we treated buck converter, boost converter, buck boost converter. So you need to have knowledge of this. So a mobile phone power bank is made up of this 1, 2, 3, 4, 5, 6 stages. So let's take a look at this here. If you want to make the power bank, these are the things you need. This is the buck boost converter module with USB ports. Then we need some lithium ion batteries. Like here, I have 4 of these lithium ion batteries in here. So let's see how this looks like. You see this is a buck boost converter module and also a charger. These are the inputs. These are the inputs for charging. There's micro USB and type C. Then these are the outputs. The input is 5 volts. The output are 5 volts. So this input is what we have here on this block. This output is what we have here on this block. Then in here we have combination of this buck converter and boost converter in here. Then we also have this stage here. We have some LEDs. If you look at it very well, 1, 2, 3, 4. There are 4 LEDs. You can see here. Then we also have a battery status check point. Then this point is where you connect your battery. So we have this in here this way, the module. So you can see from this diagram here the charger inputs. Then these are the DC outputs. The input from your charger is 5 volts. Also the output is also 5 volts. So we have this. Then if you have not seen lithium ion battery, this is lithium ion battery. You can take a look at it. You can see this type of battery, they have their name. We call them 18650. They have their own, but there are various versions of the lithium ion battery. This particular one, they have their own code. So this is 18650. So when you have about 18650 of this type, I'm holding here, and look at the current rating here, the ampacity, that is 3800 milliamp hour. And then we also have the voltage here, 3.7 volts. So most people don't understand what this milliamp hour means. Now, what this 3,800 milliamp hour is telling us the quantity of electricity this battery is holding or it can deliver. This means it can give you 3,800 milliamps in 1 hour. You understand? This battery can produce 3,800 milliamps for 1 hour. That's what it means. Or 3.8 or 3.8 amps. If you divide this by 1,000, the 1,000 milliamps equals to 1 amp. So it is 3.8 amp in 1 hour, or 3.8 amp hour. So we have these lithium ion batteries connected this way. You understand? You can have them connected this way. Now take note of this. We have the positive and the negative. Now if you look at this, there's a little sign here for you to know, and again too, they are also labeled. You can see positive and the negative. So you see this is the positive terminal and this is the negative terminal. So you take note of it. So you have them this way, all positives connected together. So you can see all the positives are connected together, and all the negatives are connected together. Then if you look at our module here, this is the positive terminal. You can see it very well, the plus and then the minus. So all the negative terminals of the battery connected together. Now you use wires to link. Make sure you have two different colors of wires so that you can be able to differentiate between the negative and the positive. So you need very pure copper or thick wires, thicker than this, the one I'm holding here, for that. So you take all the negative, you join them together, and then you bring them to the negative terminal. Then all the positive, you connect them together, you bring them to the positive terminal. So look at my DIY power bank here. This button you're seeing here is when you want to check the status of the battery. So if I press this, you're going to see, so you can see the lights in here. That's what we have here. These are 1, 2, 3, 4. You can see them. You can see the lights. So let me open this. Let's see what is inside, how I assemble this, so that you too can make yours. You know, one of the problem we have in our country here in Nigeria is power supply issues. Our grid supply is not steady, so powering some of our gadgets, we need to figure out a way of. So you can see them. I have 4 of them here, just like the way you are seeing it here. I have 4 of the batteries here. So you can see my module. It's exactly the same thing. So you can see it. So you can see them. All the positives are connected together, so like the way we are seeing here. All the positive connected together, then you all go to the positive terminal, as you can see. So all the positives through underneath, I connected them here. Then all the negatives are connected together, which goes this way. So you can see. So if you look at this, I have to use some plastic to hold this so that it will stay in place. You can see. And then I have to use some glue to hold this also, to make it more, so that it won't fall off. So you see, you can see the lights. As you can see them there, these are the lights. So in making this scene, what you need to do is just take some measurements and provide some openings, you understand, and also provide another opening here, which like the way I did here. And then I have to use some other plastic to hold this in place so that this will fit in, so that when you are plugging in your devices like this, it's not going to shift. As you can see, it's in place. Or when I want to charge, I'm plugging in this, so you can see. So let me plug this in now from the charger, so you can see it. You can see how it's showing, just like if you check the way I label this in on my cover. I have to put some transparent tape to prevent water falling in, so you see. So it's very simple. It's very simple. Just these items: the buck boost converter, the lithium ion batteries, the plastic cover, some wires, and then you also need some other tools that you need to use, some soldering iron and some hot glue. So with this, you can just simply put up what I have here. So let me put it. Now that you have seen how I made this, I believe you can quickly make yours. So these are the screws. After you just easily screw it off. So you can see. So these are, let me connect my device so that you can see it. I'm gonna my router so that I can power it with my, you see. So once it detects load is powered in, it will turn on automatically. So you see. So you can see it charging. So you can see. So when there is no load connected, after a while it will auto shut down. So you see. So it's very simple. Now this, there are, this you can easily get from electronic component shops. They are not expensive. Even this, they are almost available in any electronic component shop. Even this you can get from an electrical shop where they sell electrical fittings. You can easily get this from there. And you're buying this, make sure you buy it along with the screws, so that you, after finishing everything, you can fix it. So you can see, so there are things you can easily buy, you can easily get them. So you see. So it's very, so take, observe. Now let's go further. Now let me try to explain some certain things here. Please, if you are doing this, be very careful. Now we have some lithium ion batteries that are 3.2 volts. We will have some that are even 1.5 volt. Don't mix different voltage of batteries. Don't mix them up. Make sure you are using the same type of battery, the same type, just like the one I'm seeing now. These batteries too, they have color code. You understand? For this particular color here, this is the current rating. For this, we have blue, different color. So make sure your batteries that you are connecting make sure they are all the same type. You understand? Now let's take a look at this. If you are connecting batteries in parallel, what we have here parallel. Now, what we mean by parallel is that all the negative terminals of the battery, you use soldering iron, very hot, with soldering lead to be able to solder this. So all the negative terminals are connected together. Then all the positive terminals are connected together. That's what we mean by parallel. So you can see that's what we mean by parallel. Don't connect them this way. You connecting this. If you do this, you are connecting them in series. If you take negative, connect to positive. Yeah. If you connect batteries in series, you are increasing the voltage, but the current remains the same thing because since they are of the same current. So we are not doing series connection, it's parallel. And when you are doing parallel connection, what remains the same? The voltage. The voltage is the same thing. The voltage is the same thing. So let's find out the total capacity of the battery. Now, if you take a look at this, I didn't just write this. How did I get this? So how did I get this number? 15,200 milliamp hour. So each one is 3,800 milliamp hour. So if you multiply that by 4, you're going to get this. So the quantity of electricity. So which means this is what. Now there are some of the power banks in the market. What they usually, some of them, what they write here is fake to attract customers. Some of them, the battery in there is not even up to 3,000 milliamp hour, but they write 21,000 milliamp hour, and to attract customers, you just go and buy it. You discover that you cannot be able to charge an Android phone. So you see, so that will tell you that I didn't just write this just from here because I have 4 of them here. I have 4 of the batteries in here. So when you calculate the total capacity of the battery, you are adding up all the amp hours. So 3,800 times multiplied by 4. That's how you get 15,200. So that's why I wrote it here. Then what about this 5 volt 2.4 amps? From the manufacturer where I bought this, the manufacturer will tell you that this is 2.4 amps. So that's why I wrote it here also, so that I need to know, tell someone that this is the current this thing can give out from the USB ports. So that's so it's very, very important. Whatever you are designing, whatever is inside, indicate correctly so that you know the capacity of the power bank that you are doing. So that is all what you need to make your power bank. Now take a look at this again. If you divide this by 1000, so I can simply say 15.2 amp hour is still the same thing. Or if I say 15,200 milliamp hour is still the same thing. Milliamps, 1000 milliamps equals 1 amps. So either I say this or this, they mean the same thing. So observe the drawing very well. You can take your pen and draw this down so that you want to make yours. This will guide you. This connection is very, very important. Follow this connection strictly. Now another thing again, these batteries, they are very, very dangerous. Please, when soldering these batteries, don't allow short circuits. The positive, now the casing of this battery here is the negative terminal. So if you peel this off, you just see the negative terminal here. So prevent metal from shorting this. So if you want to solder this, make sure you have some insulators. Spray some insulators around before you solder it. Be very careful so that you don't breach it. You understand? This battery, they can explode sometimes if they are short circuited. So they are very dangerous. So handle them with care. You understand? So the connection is very, very simple. So if you are a beginner in electronics, please go to my previous videos, introduction to practical electronics, 1, 2, 3, 4, 5. Please go and study them very well so that you don't make any mistake here. Now it will be very difficult for you to make mistakes because this module is even labeled. You can even see they are labeled so that and take note, don't go and connect this something higher than this voltage that you see here. This 3.7 volt, when it is fully charged, it will go to 4.2 volts. Don't want to connect anything more than that here. You're going to destroy this module. So you understand? So take note of that. So now I believe you have understood how power banks are made. So we'll be stopping the video here. So if you like this video, please subscribe to my channel and also share it. I'm going to show you another before finally close. Let me show you something, another one again I did here. Look at this. Now I'm shooting this video. This is what is the time? Let me check the time. This is 14 minutes after 10, so 10 p.m. So you see this, take a look at this. This is solar 4-channel solar 5 volts USB power supply. So you can see the output. So this ring light I'm using here in shooting my video here, I'm powering it from here. And why this one is from you can see the light is off, so the ring light is, so you can see, look at it. Let me power the light on. So you see, so I'm powering this ring light from here. So I have 4 USB output, so which means I can put in either from your solar panel or from your batteries. You understand? Solar panel or batteries, you can power them up here, and then you have your USB output. So you see, so this is also another one. So here what we just have here, just a buck converter, step down converter. So if I put 12 volts here, I will have 5 volts at the USB output. If I put 18 volts, I will have 5 volts at the USB output. So this is another one also I designed also, you can see. So so thank you for having your time to follow us through this tutorial. So just like as I've said, please like, share, and also subscribe. Thank you. See you in our next video.